The Xeon is a brand of multiprocessing or multi-socket-capable x86 microprocessors designed and manufactured by Intel Corporation targeted at the non-consumer workstation, server, and embedded system markets. Overview: the Xeon brand has been maintained over several generations of x86 and x86-64 processors. Older models added the Xeon moniker to the end of the name of their corresponding desktop processor, but more recent models used the name Xeon on its own. The Xeon CPUs generally have more cache than their desktop counterparts in addition to multiprocessing capabilities. P6-based Xeon, Pentium II Xeon. The first Xeon-branded processor was the Pentium II Xeon. It was released in 1998, replacing the Pentium Pro in Intel's server lineup. The Pentium II Xeon was a Destitute's Pentium II with a full-speed 512 KB, 1 MB, or 2 MB L2 cache. The L2 cache was implemented with custom 512 KB SRAMs developed by Intel. The number of SRAMs depended on the amount of cache. A 512 KB configuration required 1 SRAM, a 1 MB configuration, 2 SRAMs, and a 2 MB configuration, 4 SRAMs on both sides of the PCB. Each SRAM was a 12.90 ohm by 17.23 ohm die fabricated in a 0.35 AA micrometer 4-layer metal CMOS process and packaged in a cavity-down wire-bonded land grid array. The additional cache required a larger module and thus the Pentium II Xeon used a larger slot, slot 2. It was supported by the 440GX dual-processor workstation chipset and the 450NX quad or octo processor chipset. Pentium III Xeon. In 1999, the Pentium II Xeon was replaced by the Pentium III Xeon. Reflecting the incremental changes from the Pentium II Destitute's core to the Pentium III Katmai core, the first Pentium III Xeon, named Tanner, was just like its predecessor except for the addition of streaming SIMD extensions and a few cache controller improvements. The product codes for Tanner mirrored that of Katmai. 80525. The second version, named Cascades, was based on the Pentium III Coppermin core. The Cascades Xeon used a 133 MHz bus and relatively small 256 KB on-die L2 cache resulting in almost the same capabilities as the Slot 1 Coppermin processors, which were capable of dual processor operation but not quad processor operation. To improve this situation, Intel released another version, officially also named Cascades, but often referred to as Cascades 2MB. That came in two variants, with 1 MB or 2 MB of L2 cache. Its bus speed was fixed at 100 MHz, though in practice the cache was able to offset this. The product code for Cascades mirrored that of Coppermin. 80526. Netburst-based Xeon, Xeon and Xeon MP, Foster. In mid-2001, the Xeon brand was introduced. The initial variant that used the new Netburst microarchitecture, Foster, was slightly different from the desktop Pentium IV. It was a decent chip for workstations, but for server applications it was almost always outperformed by the older Cascades cores with a 2 MB L2 cache and AMD's Athlon MP. Combined with the need to use expensive RAM-bus dynamic RAM, the Foster's sales were somewhat unimpressive. At most two Foster processors could be accommodated in a symmetric multiprocessing system built with a mainstream chipset, so a second version was introduced with a 1 MB L3 cache and a Jackson hyper-threading capacity. This improved performance slightly, but not enough to lift it out of third place. It was also priced much higher than the dual-processor versions. The Foster shared the 80528 product code with Willamette. Prestonia. In 2002 Intel released a 130 nm version of Xeon-branded CPU, codenamed Prestonia. It supported Intel's new hyper-threading technology and had a 512 KB L2 cache. This was based on the Northwood Pentium IV core. A new server chipset, E7500, was released to support this processor in servers, and soon the bus speed was boosted to 533 LMTS. The Prestonia performed much better than its predecessor and noticeably better than Athlon MP. The support of new features in the E75XX series also gave it a key advantage over the Pentium 3 Xeon and Athlon MP branded CPUs, and it quickly became the top-selling server workstation processor. Gallatin. Subsequent to the Prestonia was the Gallatin, which had an L2 cache of 1 MB or 2 MB. Its Xeon MP version also performed much better than the Foster MP, and was popular in servers. Later experience with the 130nm process allowed Intel to create the Xeon MP branded Gallatin with 4 MB cache. The Xeon branded Prestonia and Gallatin were designated 80532, like Northwood. Xeon and Xeon MP, Nocona and Irwindale. Due to a lack of success with Intel's Titanium and Titanium 2 processors, AMD was able to introduce x86-64, a 64-bit extension to the x86 architecture. Intel followed suit by including Intel 64 in the 90nm version of the Pentium 4, and a Xeon version codenamed Nocona with 1 MB L2 cache was released in 2004. Released with it were the E7525, E7520 and E7320 chipsets, which added support for PCI Express, DDR-II and serial ATA. The Xeon was noticeably slower than AMD's Opteron, although it could be faster in situations where hyper-threading came into play. A slightly updated core called Irwindale was released in early 2005, with 2 MB L2 cache and the ability to have its clock speed reduced during low processor demand. Although it was a bit more competitive than the Nocona had been, independent tests showed that AMD's Opteron still outperformed Irwindale. Both of these Prescott-derived Xeons have the product code 80546. Cranford and Potomac. 64-bit Xeon MPs were introduced in April 2005. The cheaper Cranford was an MP version of Nocona, while the more expensive Potomac was a Cranford with 8 MB of L3 cache. Like Nocona and Irwindale, they also have product code 80546. Dual-core Xeon, Paxville DP. The first dual-core CPU branded Xeon, codenamed Paxville DP, product code 80551, was released by Intel on October 10, 2005. Paxville DP had netburst microarchitecture, and was a dual-core equivalent of the single-core Irwindale with 4 MB of L2 cache. The only Paxville DP model released ran at 2.8 GHz, featured an 800 MTS front-side bus, and was produced using a 90nm process. Check quotation syntax, 7000 series Paxville MP. An MP-capable version of Paxville DP, codenamed Paxville MP, product code 80560, was released on November 1, 2005. There are two versions, one with 2 MB of L2 cache, and one with 4 MB of L2. Paxville MP, called the dual-core Xeon 7000 series, was produced using a 90nm process. Paxville MP clock ranges between 2.67 GHz and 3.0 GHz, with some models having a 667 MTS FSB, and others having an 800 MTS FSB. 7100 Series Tulsa. Released on August 29, 2006, the 7100 series, codenamed Tulsa, is an improved version of Paxville MP, built on a 65nm process, with 2 MB of L2 cache and up to 16 MB of L3 cache. It uses socket 604. 1. Tulsa was released in two lines. The N line uses a 667 MTS FSB, and the M line uses an 800 MTS FSB. The N line ranges from 2.5 GHz to 3.5 GHz, and the M line ranges from 2.6 GHz to 3.4 GHz. L3 cache ranges from 4 MB to 16 MB across the models. 5000 Series Dempsey. On May 23, 2006, Intel released the dual-core CPU codenamed Dempsey. Released as the dual-core Xeon 5000 series, Dempsey is a netburst microarchitecture processor produced using a 65nm process, and is virtually identical to Intel's Pressler Pentium Extreme Edition, except for the addition of SMP support, which lets Dempsey operate in dual-processor systems. Dempsey ranges between 2.50 GHz and 3.73 GHz. Some models have a 667 MTSFSB, and others have a 1066 MTSFSB. Dempsey has 4 MB of L2 cache. A medium-voltage model, at 3.2 GHz and 1066 MTSFSB, has also been released. Dempsey also introduces a new interface for Xeon processors, LGA 771, also known as Socket J. Dempsey was the first Xeon core in a long time to be somewhat competitive with its Opteron-based counterparts, although it could not claim a decisive lead in any performance metric that would have to wait for its successor, the Woodcrest. Pentium M-based Xeon, LV, ʻziːʒn. On March 14, 2006, Intel released a dual-core processor codenamed ʻziːʒn and branded as Xeon LV. Subsequently a new LV version was released. The ʻziːʒn was a low/ultra-low power and double processor-capable CPU, based on the Iona processor, for ultra-dense non-consumer environment, and was rated at a thermal design power of 31W and 15W. As such, it supported most of the same features as earlier Xeons: virtualization technology, 667 LMTS front-side bus, and dual-core processing, but did not support 64-bit operations, so could not run 64-bit server software, such as Microsoft Exchange Server 2007, and therefore was limited to 16 GB of memory. A planned successor, codenamed MeRAM-MP, was to be a drop-in upgrade to enable ʻziːʒn-based servers to upgrade to 64-bit capability. However, this was abandoned in favor of low-voltage versions of the Woodcrest LV processor, leaving the ʻziːʒn at a dead end with no upgrade path. Core-based Xeon, dual-core, 3000 series Conroe. The 3000 series, codenamed Conroe dual-core Xeon CPU, released at the end of September 2006, was the first Xeon for single CPU operation. The same processor is branded as Core 2 Duo or as Pentium Dual Core and Celeron, with varying features disabled. They use LGA 775, operate on a 1066 MHz front-side bus, support enhanced Intel speed step technology and Intel virtualization technology but do not support hyper-threading. Conroe processors with a number ending in 5 have a 1333 LMTSFSB. Models marked with a star are not present in Intel's database. 3100 series Wolfdale. The 3100 series, codenamed Wolfdale dual-core Xeon CPU, was just a rebranded version of the Intel's mainstream Core 2 Duo E7000/E8000 and Pentium dual-core E5000 processors, featuring the same 45 nm process and 6 MB of L2 cache. Unlike most Xeon processors, they only support single CPU operation. They use LGA 775, operate on a 1333 MHz front-side bus, support enhanced Intel speed step technology and Intel virtualization technology but do not support hyper-threading. 5100 series Woodcrest. On June 26, 2006, Intel released the dual-core CPU codenamed Woodcrest. It was the first Intel Core microarchitecture processor to be launched on the market. It is a server and workstation version of the Intel Core 2 processor. Intel claims that it provides an 80% boost in performance, while reducing power consumption by 20% relative to the Pentium D. Most models have a 1333 LMTSFSB, except for the 5110 and 5120, which have a 1066 MTSFSB. The fastest processor operates at 3.0 GHz. All Woodcrests use LGA 771 and all except 2 models have a TDP of 65 AW. The 5160 has a TDP of 80 AW and the 5148 LV has a TDP of 40 AW. The previous generation Xeons had a TDP of 130 AW. All models support Intel 64, the XD-bit, and virtualization technology, with a demand-based switching power management option only on dual-core Xeon 5140 or above. Woodcrest has 4 MB of shared L2 cache. 5200 series Wolfdale DP. On November 11, 2007, Intel released the dual-core CPU codenamed Wolfdale DP. It is built on a 45nm process like the desktop Core 2 Duo and Xeon SP Wolfdale, featuring Intel 64, the XD-bit, and virtualization technology. It is unclear whether the demand-based switching power management is available on the L5238. Wolfdale has 6 MB of shared L2 cache. 7200 series Gallatin. The 7200 series, codenamed Gallatin, is an MP-capable processor, similar to the 7300 series, but, in contrast, only one core is active on each silicon chip, and the other one is turned off, resulting as a dual-core capable processor. 2, 3, 4, 5, quad-core and multi-core Xeon, 3200 series Kentsfield. Intel released relabeled versions of its quad-core Core 2 quad processor as the Xeon 3200 series on January 7, 2007. The 2AA, A2 quad-core comprise 2 separate dual-core die next to each other in one CPU package. The models are the X3210, X3220 and X3230, running at 2.13 GHz, 2.4 GHz and 2.66 GHz, respectively. Like the 3000 series, these models only support single CPU operation and operate on a 1066 MHz front-side bus. It is targeted at the blade market. The X3220 is also branded and sold as Core 2 Quad Q6600, the X3230 is Q6700. 3300 series Yorkfield. Intel released relabeled versions of its quad-core Core 2 Quad Yorkfield Q9400 and Q9X50 processors as the Xeon 3300 series. This processor comprises 2 separate dual-core dies next to each other in one CPU package and manufactured in a 45nm process. The models are the X3320, X3350, X3360, X3370 and X3380, running at 2.50 GHz, 2.66 GHz, 2.83 GHz, 3.0 GHz, and 3.16 GHz, respectively. The L2 cache is a unified 6 MB per die, and a front-side bus of 1333 MHz. All models feature Intel 64, the XD-bit, and virtualization technology, as well as demand-based switching. The Yorkfield CL variant of these processors are X3323, X3353 and X3363. They have a reduced TDP of 80W and are made for single CPU LGA 771 systems instead of LGA 775, which is used in all other Yorkfield processors. In all other respects, they are identical to their Yorkfield counterparts. 5300 series Clovertown. A quad-core successor of the Woodcrest for DP segment, consisting of 2 dual-core Woodcrest chips in one package similarly to the dual-core Pentium D branded CPUs or the quad-core Kentsfield. All Clovertowns use the LGA 771 package. The Clovertown has been usually implemented with 2 Woodcrest dies on a multi-chip module, with 80 MB of L2 cache. Like Woodcrest, lower models use a 1066 MTSFSB, and higher models use a 1333 MTSFSB. Intel released Clovertown, product code 80563, on November 14, 2006 with models E5310, E5320, E5335, E5345, and X5355, ranging from 1.6 GHz to 2.66 GHz. All models support MMX, SSE, SSE2, SSE3, SSSE3, Intel 64, XD-bit, Intel VT. The E and X designations are borrowed from Intel's Core 2 model numbering scheme. An ending of a 0 implies a 1066 MTSFSB, and an ending of a 5 implies a 1333 MTSFSB. All models have a TDP of 80W with the exception of the X5355, which has a TDP of 120 AW. A low-voltage version of Clovertown with a TDP of 50 AW has a model numbers L5310, L5320 and L5335. The 3.0 GHZX5365 arrived in July 2007, and became available in the Apple Mac Pro 6 on April 4, 2007. 7. The X5365 performs up to around 38 GFLOPS in the Linpack benchmark. 8. 5400 Series Harpertown. On November 11, 2007, Intel presented Yorkfield-based Xeon's Euro called Harpertown Euro to the public. 9. This family consists of dual-die quad-core CPUs manufactured on a 45nm process and featuring 1066 MHz, 1333 MHz, 1600 MHz front-side buses, with TDP rated from 40 AW to 150 AW depending on the model. These processors fit in the LGA 771 package. All models feature Intel 64, the XD-bit, and virtualization technology. All except the E5405 and L5408 also feature demand-based switching. The supplementary character in front of the model number represents the thermal rating, an L depicts a TDP of 40 AW or 50 AW, an E depicts 80 AW whereas an X is 120 AW TDP or above. The speed of 3.00 GHz comes as 4 models, 2 models with 80 AW TDP, 2 other models with 120 AW TDP with 1333 MHz or 1600 MHz front-side bus respectively. The fastest Harpertown is the X5492 whose TDP of 150 AW is higher than those of the Prescott-based Xeon DP but having twice as many cores. Intel 1600 MHz front-side bus Xeon processors will drop into the Intel 5400 chipset, whereas several mainboards featuring the Intel 5200 chipset are enabled to run the processors with a 1333 MHz front-side bus speed. Seeburg features support for dual PCIe 2.0x16 slots and up to 128 GB of memory. 7300 Series Tigerton. The 7300 series, codenamed Tigerton, is a 4-socket and more capable quad-core processor, consisting of 2 dual-core Core 2 architecture silicon chips on a single ceramic module, similar to Intel's Xeon 5300 series Clovertown processor modules. The 7300 series uses Intel's Kaneland platform. Intel claims the 7300 series Xeons offer more than twice the performance per watt as Intel's previous generation 7100 series. The 7300 series Kaneland chipset provides a point-to-point interface allowing the full front-side bus bandwidth per processor. The 7xxx series is aimed at the large server market, supporting configurations of up to 32 CPUs per host. 7400 series Dunnington. Dunnington Euro, the last CPU of the Penryn generation and Intel's first multi-core die Euro, features a single die 6-core design with 3 unified 3 MBL2 caches, and 96 KBL1 cache and 16 MB of L3 cache. It features 1066 MHz FSB, fits into the Tigerton's MPGA 604 socket, and is compatible with both the Intel Kaneland and IBM X4 chipsets. These processors support DDR2-1066, and have a maximum TDP below 130 AW. They are intended for blades and other stacked computer systems. Availability was scheduled for the second half of 2008. It was followed shortly by the Nehalem microarchitecture. Announced on September 15, 2008. Intel Link, Nehalem-based Xeon 3400 series Linfield. Xeon 3400 series processors based on Linfield fill the gap between the previous 3300 series Yorkfield processors and the newer 3500 series Bloomfield. Like Bloomfield, they are quad-core single-package processors based on the Nehalem microarchitecture, but were introduced almost a year later, in September 2009. The same processors are marketed for mid-range to high-end desktop systems as Core i5 and Core i7. They have 2 integrated memory channels as well as PCI Express and Direct Media Interface links, but no Quick Path Interconnect interface. 3400 Series Clarkdale. At low end of the 3400 series is not a Linfield but a Clarkdale processor, which is also used in the Core i3-500 and Core i5-600 processors as well as the Celeron G1000 and G6000 Pentium series. A single model was released in March 2010, the Xeon L3406. Compared to all other Clarkdale-based products, this one does not support integrated graphics, but has a much lower thermal design power of just 30 W compared to the Linfield-based Xeon 3400 models. It only offers 2 cores. 3500 series Bloomfield. Bloomfield is the code name for the successor to the Xeon Core microarchitecture, is based on the Nehalem microarchitecture and uses the same 45nm manufacturing methods as Intel's Penryn. The first processor released with the Nehalem architecture is the desktop Intel Core i7, which was released in November 2008. This is the server version for single CPU systems. This is a single-socket Intel Xeon processor. The performance improvements over previous Xeon processors are based mainly on integrated memory controller supporting 3 memory channels of DDR3 UDIMM or RDIMM, a new point-to-point processor interconnect quick path, replacing the legacy front-side bus, simultaneous multi-threading by multiple cores and hyper-threading. 5500 series Gainestown. Gainestown or Nehalem EP, the successor to the Xeon Core microarchitecture, is based on the Nehalem microarchitecture and uses the same 45nm manufacturing methods as Intel's Penryn. The first processor released with the Nehalem microarchitecture is the desktop Intel Core i7, which was released in November 2008. Server processors of the Xeon 55XX range were first supplied to testers in December 2008. The performance improvements over previous Xeon processors are based mainly on integrated memory controller supporting 3 memory channels of DDR3 SDRAM. A new point-to-point processor interconnect quick path, replacing the legacy front-side bus. Gainestown has 2 quick path interfaces. Hyper-threading, that was already present in pre-Core Duo processors. C3500 per carat 5500 series Jasper Forest. Jasper Forest is a Nehalem-based embedded processor with PCI Express connections on die, core counts from 1 to 4 cores and power envelopes from 23 to 85 watts. The uniprocessor version without QPI comes as LC35XX and EC35XX, while the dual processor version is sold as LC55XX and EC55XX and uses QPI for communication between the processors. Both versions use a DMI link to communicate with the 3420 that is also used in the 3400 series Linfield Xeon processors, but use an LGA1366 package that is otherwise used for processors with QPI but no DMI or PCI Express links. The CPU ID code of both Linfield and Jasper Forest is 106X, that is Family 6, Model 30. The Celeron P1053 belongs into the same family as the LC35XX series, but lacks some RAS features that are present in the Xeon version. 3600 5600 series Gulftown, and Westmere EP. Gulftown or Westmere EP, a 6-core 32nm Westmere-based processor, is the basis for the Xeon 36XX and 56XX series and the Core i7-980X. It launched in the first quarter of 2010. The 36XX series follows the 35XX series Bloomfield uniprocessor model while the 56XX series follows the 55XX series Gainestown dual processor model and both are socket compatible to their predecessors. 6500 7500 series Beckton. Beckton or Nehalem X is a Nehalem-based processor with up to 8 cores and uses buffering inside the chipset to support up to 16 standard DDR3 DIMMs per CPU socket without requiring the use of FB-DIMMs. Unlike all previous Xeon MP processors, Nehalem X uses the new LGA1567 package, replacing the socket 604 used in the previous models, up to Xeon 7400 Dunnington. The 75XX models have 4 quick path interfaces, so it can be used in up to 8 socket configurations, while the 65XX models are only for up to 2 sockets. Designed by the Digital Enterprise Group Santa Clara and Hudson design teams, Gallatin is manufactured on the P1266 technology. Its launch in March 2010 coincided with that of its direct competitor, AMD's Opteron 6xxx Megni cores. Most models limit the number of cores and QPI links as well as the L3 cache size in order to get a broader range of products out of the single-chip design. E7X8XX Series Westmere X. Westmere X is the follow-on to Gallatin Nehalem X and the first Intel chip to have 10 CPU cores. The microarchitecture is the same as in the 6-core Gulftown Westmere EP processor, but it uses the LGA 1567 package like Gallatin to support up to 8 sockets. Starting with Westmere X, the naming scheme has changed once again, with E7XXXX now signifying the high-end line of Xeon processors using a package that supports larger than 2 CPU configurations, formerly the 7XXX series. Similarly, the 3xxx uniprocessor and 5xxx dual processor series turned into E3xxxx and E5xxxx, respectively, for later processors. Sandy Bridge-based Xeon E3-12XX series Sandy Bridge. The Xeon E3-12XX line of processors, introduced in April 2011, uses the Sandy Bridge chips that are also the base for the Core i3-i7-2XXX and Celeron Pentium GXXX products using the same LGA 1155 socket, but with a different set of features disabled. Notably, the Xeon variants include support for ECC memory, VTD and trusted execution that are not present on the consumer models, while only some Xeon E3 enable the integrated GPU that is present on Sandy Bridge. Like its Xeon 3400 series predecessors, the Xeon E3 only supports operation with a single CPU socket and is targeted at entry-level workstations and servers. The CPU ID of this processor is 0206A7H, the product code is 80623. E3-12XX V2 Series IV Bridge. Xeon E3-12XX V2 is a minor update of the Sandy Bridge-based E3-12XX, using the 22nm shrink, and providing slightly better performance while remaining backwards compatible. They were released in May 2012 and mirror the desktop Core i3-i7-3XXX parts. E5-14XX/24XX series Sandy Bridge ʻziːn, and E5-16XX46XX series Sandy Bridge EP. The Xeon E5-16XX processors follow the previous Xeon 3500-3600 series products as the high-end single-socket platform, using the LGA 2011 package introduced with this processor. They share the Sandy Bridge E platform with the single-socket Core i7-38XX and i7-39XX processors. The CPU chips have no integrated GPU but 8 CPU cores, some of which are disabled in the entry-level products. The Xeon E5-26XX line has the same features but also enables multi-socket operation like the earlier Xeon 5000 series and Xeon 7000 series processors. E5-14XX V2/24XX V2 series IV Bridge ʻziːn, and E5-16XX V2/26XX V2/46XX V2 series IV Bridge EP. The Xeon E5 V2 line was an update, released in September 2013 to replace the original Xeon E5 processors with a variant based on the Ivy Bridge shrink. The maximum number of CPU cores was raised to 12 per processor module and the total L3 cache was up to 30 MB. The consumer version of the Xeon E5-16XX V2 processor is the Core i7-48XX and 49XX. E7-28XX V2/48XX V2/88XX V2 series IV Bridge X. The Xeon E7 V2 line was an update, released in February 2014 to replace the original Xeon E7 processors with a variant based on the Ivy Bridge shrink. There was no Sandy Bridge version of these processors. Horsewell-based Xeon, E3-1XXXV3 series Horsewell. Introduced in May 2013, Xeon E3v3 is the first Horsewell microarchitecture-based Xeon. It uses the new LGA1150 socket, which was introduced with the desktop Core i5/i7 Horsewell processors and is not compatible with the LGA1155 that was used in Xeon E3 and E3v2. As before, the main difference between the desktop and server versions is added support for ECC memory in the Xeon-branded parts. The main benefits of the new microarchitecture are better power efficiency and a faster GPU. Supercomputers. By 2013, Xeon processors are ubiquitous in supercomputers. More than 80% of the top 500 machines in 2013 used them. For the very fastest machines, much of the performance comes from compute accelerators. Intel's entry into that market was the Xeon Phi. The first machines using it appeared in the June 2012 list, and by June 2013 it was used in the fastest computer in the world. The first Xeon-based machines in the top 10 appeared in November 2002, 2 clusters at Lawrence Livermore National Laboratory and at NOAA. The first Xeon-based machine to be in the first place of the top 500 was the Chinese Tianyi IA in November 2010, which used a mixed Xeon NVIDIA GPU configuration. It was overtaken by the Japanese K-Computer in 2012, but the Tianyi 2 system using 12-core Xeon E5-2692 processors and Xeon Phi cards occupied the first place in both top 500 lists of 2013. The SuperMUC system, using 8-core Xeon E5-2680 processors but no accelerator cards, managed 4th place in June 2012 and had dropped to 10th by November 2013. Xeon processor-based systems are among the top 20 fastest systems by memory bandwidth as measured by the Stream benchmark. An Intel Xeon virtual SMP system leveraging Scale MP's versatile SMP architecture with 128 cores and 1 TB RAM. This system aggregates 16 Stackley platform systems with total of 32 Harper-Town processors. See also, Intel Xeon Phi, brand name for family of products using the Intel MIC architecture, list of Intel Xeon microprocessors, list of Intel microprocessors, references. External links, server processors at the Intel website.